Is the screen visible, ma'am?
Yes, yes, sir. Please continue.
Okay. See, good afternoon, Manada. Till now, what we have discussed is first day architecture and vision of smart electric grid, then installation capacities, then we'll move to history of renewable and PV systems. Then we have also looked after materials used in PV systems and mathematical modeling of PV array, PV cell, and PV modules. Then about standalone and grid current systems, yesterday we have discussed, and partial shading conditions also we have seen. Then today we are going to see mainly on these are all the things we have discussed. What are the solar parks available in India? And after that, we are going to see uh, then applications of solar energy systems. Mainly, I will try to explain you today the modeling of the PV systems. Like MATLAB session, I'm going to explain you today how to design PV cell and PV module and PV arrays in MATLAB during normal conditions as well as during shading conditions. Okay, so these are all the things I have explained you yesterday. So let me go directly there. We will see there are 10 largest solar farms in India. It is available. Okay, so the first one is Badla Solar Park. Okay, so first one is Badla Solar Park. It is Badla Solar Park is in Rajasthan. Okay, it is not only largest solar plant in India, it is the largest solar farm in the world. Okay, it is not only largest plant in India, it is the largest solar plant or solar farm in the world. Okay, the installation capacity is 2245 megawatts. Fine, the 2245 2245 megawatt is the capacity of the solar plant. Okay, the amount of electricity which produces from the solar plant, okay, which can cover a power of over 1 million houses can be supplied. Okay, the amount of energy produces the power over 1 million houses it can be given. Okay, it is located in the Thar desert. Okay, so it is spread over 56 square kilometers. 56 square kilometers it is spread. So it is like different phases wise they have constructed. Okay, the first phase it was initialized in 2018 and installation capacity was 420 megawatt. Second phase is by December it was completed and it is 250 megawatt, and then 1000 megawatt in third phase they have considered within a year, that is December 2019. Next 2020 they have considered 775 megawatt. What they have done, it is the entire this plant is in collaboration with NTPC, National Thermal Power Corporation, and Solar Energy Corporation of India, SCCA. NTPC and SCCA, Solar Energy Corporation India, together they have signed a MOU of 25 years they have done. Okay, so this is what the first one is, the highest one, 2245 megawatt is there. This is the first one. And when it comes to the second one, second is Pavgada Solar Park we have, that is in Tumkur, 2050 megawatts it is generating. Then it is in Andhra Pradesh, third one Anantapur, this 1500 megawatt is there. Karnool, 1000 megawatt is there. Then Reva, so then Komati, Tamil Nadu it is there, Madhya Pradesh, Rajasthan, Gujarat. So let me show you that also. When it comes to the Pavgada Solar Park, so as I said, it is also massive solar park. So it is the second highest. Okay, so 13,000 acres of land in the Tumkur district. It was initially planned 2000 megawatt, but after that 50 megawatt they have added. So total it is 2050 megawatt. So after adding that 50 megawatt, it become one of the okay uh, largest power plants in India. Okay, second largest, third largest. Second largest is China's. Okay, so here when they have started, they have formulated in 2015. Okay, and its development commenced in 2016. So as of 2021, it holds the as I said third largest photovoltaic system in the world. It is world's third largest solar park. Second one is holding by China. Okay. So from here, how much they are doing? So here it is, as I said, the largest power plant 2020 245 by Rajasthan, 2200 megawatt by that Hungary. China is the second place, and third is Pavagada power plant. Okay, here what you should know is the total area of the solar park is 13,000 acres, and total capacity is 2050 megawatt, and the amount invested for this project is 16,500 crores. Okay, towards the sustainable development, 16,500 crores are allotted for exclusively this project. Okay, here also NTPC 600 megawatts is implemented out of 2050, while Solar Energy Corporation of India, Karnataka Renewable Power Generation, so solar energy 200 megawatts, Karnataka State Powers, it is 1250 they have installed. Okay, out of 2050, 600 is megawatt is installed by NTPC, and 200 megawatt is installed by which one? The Solar Energy Corporation of India, and 1250 megawatt is installed by Karnataka Renewable Energy. Okay, that is state government. Okay, so here with the help of this, they have 5,78,631 tons of the carbon emissions they have mitigated. Understood? So first one was the largest in the world, 2,245, and 56 square kilometers it is expanded. Okay. Second one is 13,000 across 2050, and amount spent is 13,500. Both the places common is NTPC, SCCA is common, but here in the second one, the Karnataka state also it is there is a partially they have considered. And next one, Anantapuram, it is in Andhra Pradesh, 1500 megawatts they are generating. Okay, so it is an ultra mega solar park, solar it is called. So it is expanded in 32 square meters, that means 7,900 acres it is expanded. Okay, and it is two phases they have considered. It is also in corporate, it is also in combining with they developed with NTPC only. Okay, so first they have planned 250 megawatt, then after that 750 megawatt they have planned. Okay, together 1000 megawatt, after that 500 megawatt they have added. Okay, so now the overall cost for this is 6,000 crores, and it can give the power to 8 lakh houses. Okay, so it is expanded in 7,907 acres, partially supported by NTPC, and project cost is 6,000 crores. The project capacity is 1500 megawatt, but as of now, operation is only 1000 megawatt. As of now, operation is 1000 megawatt. Why? So 2016 250 megawatt they have installed. Latest is 750 megawatt they installed. 500 megawatt they are yet to develop. Okay, so next Kurnool power plant is there. The Kurnool power plant also it is same, it is in Andhra only. Okay, it is expanded, next highest 1000 megawatt is there. So 24 square kilometers it expanded, almost 6,000 across. Okay, they use the panels of 315 to 320 watts. Okay, its efficiency is it is integrated with 220 by 33 kV systems and 400 by 220 kV subsystems. Okay, so here this is also the amount is sanctioned from MNRE under a state specific building scheme, and NTPC also selected as implementing agency. Implementing agency is thermal power plant only. Okay, so this is the third. So 5,900 acres and 1000 megawatt capacity. Okay, funding by MNRE and they are going to implement with the agents in collaboration with NTPC. Okay. Next, Rewa mega power plant is there. Which is in Madhya Pradesh. This is also 750 megawatt. Okay. They are also in collaboration with Solar Energy Corporation of India. They have started, and it is expanded over 6.4 kilometers square. Okay. Similarly, we have Kumti also. So it is expanded over. It is in Tamil Nadu. 650 megawatt approximately 10 square kilometers it is expanded. So now these are the upcoming projects. As I said, Anantapuram 2, no, it's 400 more megawatt they are going to add, and after that Galwid also 400 megawatt. These are the more upcoming solar power plants which they are going to consider. So if you see, now most of the solar parks they are going to implement. So here what happened, so this is this operator is Solar Energy Corporation, whereas NTPC also they are implementing some plans. Okay, so these are the main things. Okay, Badla is 2245, Pavagada 2050, the Karnool is 1000, and Kunta, whichever I considered Anantapuram, that is 1000 they have installed till now, but later they are going to install 500 more. Then there is Jaisalmer is there, then Rewa is there, Tamil Nadu. These are the top 10 solar projects in India. Okay. So these are the places. So where we have, okay, the Badla in Rajasthan, Jaisalmer 925, Patna we have, then even Kadak also they have proposed 7,500. Even Rewa we have Madhya Pradesh, then Uttar Pradesh Jalan is there. Okay, then Andhra Pradesh two plants are there. One is Karnool, one is in Anantapuram, then Tamil Nadu, Ramanathapuram. So it is spread across different places where the sun will be very high. These are the biggest plants I'm talking about. So there are other small plants are there in various locations, but these are the majority of largest power plants, solar power plants, which are available in India. Now we will see some applications. Okay, so there are numerous applications the solar energy can be used. The first one is solar water pumping, mainly rural applications. When see, sometimes the farmers will face the problem due to power cut in the villages. So this is the best solution, solar powered water pumping system. This is the one of the best solution. So what, so he don't need to depend upon the particular power. Is it that much distance, is the power cabling is there or not? Otherwise you need to depend upon other landlords. Okay, so who you need to borrow something. So rather than that, you can have your own solar plant at your field, and you can use water pumping system. Applications can be used, even it can be used for agricultural purpose, or it can be used for at your home also. Even water heating system is there. So now solar water heaters also available. Okay, so that is water pumping system. Even solar water heaters were there. Second one is, nowadays people, everywhere you can observe, almost most of the places we have solar PV powered street lighting system we're considering. So what is happening, the street lights are provided with solar PV panels. So one is, it will extract the power and it tries to give when it is required. Okay, morning time the power will be stored, and evening time it can discharge the power. Then this is quite growing area. The most of the places people are installing PV powered street light system. Here one more advancement can be done. If suppose excess power is there, small battery can be kept and the data can be stored. It can be smart EV charging. So smart EV charging. So what we can be done, morning time which is not required. Then morning time when the excess power is there, excess power can be stored in the battery, and that power can be night time it can be discharged. Second thing, even we can add some sensors in such a way that, so based on the climatic condition, based on the light intensity, so automatically turn on, automatically turn off of lights also can be utilized. That logic also can be implemented here. So we can use Arduino control and we can automatically turn off the light and turn. See, sometimes when you see, so there is outside, even morning time also lights are on. So we can avoid that, and based on timing wise we can use fixed timings. This particular time only should turn off automatically, or else based on the density, based on the climate conditions, how much it is, the power is there, how much amount of, based on some particular inputs can be taken. If it is dark, automatically turn on. If it is bright, then it will be turned off. So conditions can be taken, and even you can add even timings also. Early hours with less intensity, even evening hours with more intensity. The brightness of the light also can be automatically controlled. So, which by using some sensors, even you can make smart solar PV street lighting system can be adapted. You can take that application. Next, main huge applications. The best application which is implemented is the primary application, I can say, that is solar PV powered space satellite. So we don't have any other option in the satellites for the, we need to consider solar PV systems, which will extract the power and it will be given to the satellites. Okay, so there is no other alternative we have. So compulsory the majority, then the people are considering solar PV panels, and nicely it can be used for space applications. And as I said, solar water pumping also nowadays people are using. So water heaters people will keep. So solar powered water heaters when we keep, so it will charge and it will be discharged through the tank, and so we will get nice hot water can be achieved. So solar water heater systems also nowadays, even in the market it is available. Okay. Next is solar powered cookers. In early days, ancient days, it was available. Even now also it is available. Okay. So here we have a reflector, inner metal box will be there, glass sheet cover, and food container can be kept, place will be there. Then outer wooden box will be there. So the reflector will extract the powers and then it tries to cook them. But it is not that much, okay, well taken. But most of the applications are pumping applications are highly utilized. Street light applications are majority is used, and even solar PV powered space satellites are majority they have used, and water pumping, water heater system also we are using. Okay, and the last one is solar PV powered cold storages also the people are considering. So these are the main applications, 6 applications where the people are, majority of the people are utilizing this. Okay. So even I told you in the last class, to extract the maximum power during shading condition, yes, we can go ahead with different maximum power point techniques are there. So that is conventional MPPT techniques are there. There are conventional MPPT techniques, intelligent MPPT techniques, optimization based hybrid MPPT techniques are there. Okay, so as I said, conventional is P&O algorithm, incremental conductance, hill climbing method. These are the basic algorithms which everywhere they will use. But intelligent technique in the sense by using fuzzy logic controller, artificial neural network, okay, AI based and Fibonacci series, okay. So sliding mode control, these are comes under intelligent techniques. Optimization is SWAM optimization techniques. Okay, SWAM intelligence, that is article SWAM optimization, gray wolf optimization, handway colony, bat algorithm, genetic algorithms, cuckoo search. So these are all are comes under optimization techniques. Now hybrid means a combination of any two can be taken and the hybrid can be made. So there are different MPPT maximum power point techniques are there which will be used during partial shading condition happen. If shading is there, you can't track the maximum power. To track the maximum power, we can add MPPT technique so that the, we can enhance the tracking of the maximum power. Okay. So as I told you previously, uh, to model any PV system, so I'm going to start the MATLAB session. So we have different type of conventional PV configurations are there. Just 2 minutes I'll recall. We have a series PV configuration, parallel, series parallel, bridge link, honeycomb, triple tried, total cross tried is there, or hybrid configuration of combination of any of the above, like series parallel TCT, bridge link TCT, honeycomb TCT, or bridge link honeycomb, any combination can be taken. Now these are all the things what we are doing. Now these configurations has to be tested under different shading conditions. We can have, so there is one row shading can happen, one column shading can happen, some corner shading can happen, center point, center of the PV panel shading can happen, some diagonal shading, or maybe randomly shading can happen. There is a frame shading, L-shape shading is there. Okay, so different type of shading patterns are there during shading conditions. So we need to analyze some parameters. What is that? Mismatching losses, how much amount of fill factor is there, what is the efficiency, okay, what is open circuit voltage, what is short circuit current, how much amount of local global maximum we can achieve, how many local peaks are there. These are all the things need to be analyzed. Now we have different type of configurations, reconfigurations are there. These to be tested under different shading conditions. During that, we need to measure these evaluation parameters. Fine. Let me show you. Last time I have explained you already. So different shading conditions are, just you see, due to cloud there is a shading can happen, due to neighboring structure, yes, because of building is very high, here PV panels are on lower height, then because of this shading can happen. Even one PV module is little bit height, another PV module is less height, due to mutual shading, due to because of this a small portion is shaded, you see. Due to soiling, shading can happen. Due to board chippings, there is a shading can happen. At top of your house, chimney is there. You avoid the chimney and you are considered. But the place, okay, due to chimneys also, shading can happen, or snow can be fallen on that. So there are various different things are there. Even previously, when you observe, all the solar parks are located in the deserts. How much we got? So these places are located in 10 square kilometers, or maybe in terms of thousands of acres it is there. Where it is there? It is there in deserts. Try to see. It is in where it is Thar desert. Badla is in Thar desert. So there you can't expect any shading. Where there is no shading, there maximum power people are extracting with the help of solar farms. Even Pavagad also nearby the deserts only they consider. Nearby there is no shading effect. Even Anantapuram also, the 7,900 acres are in the desert only. Okay, everywhere what they considered is mostly nearby deserts they will consider there is no shading effects. But rooftop PV systems if you consider, or maybe commercial buildings if you consider PV system, or EVPV charging stations if you consider these systems, then there is a chances of for residential, commercial, or normal industry, as well as then when you consider for EVPV charging infrastructure, there we can notice there are partial shading applications, real-time applications. But solar farms, chances are very rare. So during these conditions, these applications, how to measure? So now you try to see these are the shading conditions can happen, realistic conditions. Now those things will be represented like this. Okay, shading of frame shading can be represented like this, diagonal shading. So as I said, suppose the center is very high shading is happened. Suppose there is some cloud is there, middle one is highly shaded, next ones are less shaded. There is a tree structure is there, the middle one is completely shaded, but next parameters are very less shaded, that is of diagonal shaded. It can happen only one panel it can happen, or more panels also can be happen, that is called diagonal. Corner shadings, suppose all four corners, sometimes some buildings are there, some buildings corner sides little bit of there is a little height of pillar will be there. So if you have a four corners, some pillars or some trees are there, there is a possibility corner shading also can happen, either one corner can happen or four corners also can happen. So there is a short and narrow, so completely L type structure with a little bit of less intention. Okay, this is a corner shading. even long and wide. So there are different way, random shading. Okay, this is no shading. Last one is without shading. So these are the different shading conditions we are going to consider. So the 3D diagram of the corner shading is this. In MATLAB we can draw this, and center shading is like this. Okay, 1000 watt, 0 to. Okay. Then right side shading, left side of panel shading is there. Then there is L-shape shading is there. The frame shading of middle. Then there is diagonal shading, random shading. So different ways we can consider. Okay. Now I'll go to MATLAB. To model PV array configuration, we have a different types of PV modules are there. Few are with 200 watt, few are with 250 watt, 300 watt, 350 watt, even 500 watt of PV panels also available. So what we need to do? So we need to consider exact proper PV models need to be selected. When we select a PV model, what data will be available? Okay, we should understand which data is available. On the PV panel specifications, we will have a maximum power is how much? What is the voltage at maximum power point of one module? Uh, current maximum, current at maximum power point, what is the value of this panel? And what is the open circuit voltage, what is the short circuit current, what is the temperature coefficient of open circuit and temperature coefficients of short circuit current, number of cells in series per module, how many are there, series resistance how much, shunt resistance how much, diode factor. So these are all the parameters of PV system is given there. Okay, whatever you select, that PV module will have this data. Now these PV modules can be connected in series or parallel. This is for one module data. I'm talking about one module data. Okay. Now these type of modules. Now what I have taken for a simulation, 7x7 PV array I have taken. That means 49 modules of this one. Then 49 into approximately 200 or 200.143. So what is the capacity? Capacity 200 into 49 or 200.143 into 49 panels, approximately
9,800.
Yes. So I have designed for approximately 10 kilowatt, 9,800. So now you see, when we consider 7 by 7 PV array structure, 7 by 7 PV array structure, now you see 7 modules are first string are there, second string also 7 modules. So since it is a series configuration, all 49 modules are connected in series. You can see the 7 by 7 structure, all 49 modules are connected in series. So I already explained you. So how much it will be? The currents will be module current, voltage will be 49 into that value. So how I have simulated during uniform condition, corner shading, whatever the conditions I have taken here. During different shading conditions I have taken here. I will show you that results MATLAB simulation. So this is under uniform condition. Okay. So voltage versus which one? Current. IV curve it is called. Second one is PV curve. So try to understand this module. I have taken 200 watt, one module. So power of 49 modules is, it will be 9,800. What about voltage? Voltage will be how much? 49 modules you have taken. So voltage will be how much? Excuse me. So voltage need to be multiplied with 49 into VMP, no? How much it is? See, in series, the voltage is multiplied. So how much it is?
It is
49.
1288.
If it is, if you consider VMP, it is 1288. But
Yes.
I should consider short circuit current. Short circuit, how much it is? So sorry, open circuit voltage.
Open circuit, that's what it should be greater than that.
Open circuit voltage is 32.9. So how much it will come? Can you calculate, sir? Just one example I tell.
32.9, no?
32.9 into 49.
49. Yeah, it is 296.8.
No. 49 into 32.9.
Sorry, 32.9 into 49.
Approximately 1600 you should get.
16.
Yes, yes. So 1612 volts is there.
Yes.
Now current will be how much? Current of one module only, series connection. Current is in a series configuration, current should be one module current only, no? 8.2.
8.2.
Okay. Now current versus voltage, I versus V, if I draw, voltage is how much? 1600.
Yes.
Current is 8. This is ideal condition. Whatever you said that 1200, no, but what is that VMP difference? I am telling you,
Yes.
1600 is short circuit voltage, sorry, open circuit voltage, 8.21 is short circuit current. But what is VMP? VMP IMPs are, you try to see, voltage at maximum power point or current at maximum power point, that is 7.61, 26.3. This is the maximum power point.
Sir, this deviation is there from OCC and VMP and VOC. Is it because of the fill factor?
Yes, sir. Yes. Because of fill factor, how much it is covered, how much amount of shade. Yes.
That is because
of
fill factor.
Fill factor. For a PV panel, you can't extract maximum power. So it is, you see,
right.
This is 26.3. Whatever you said, 1288. No, that much you will get.
Yes, yes.
VMP into that 49. And here current also some 7.6 something you will get at this maximum power point value. Now this is ideal curve. Now if shading is happened, corner shading, then there is a local maximas you are getting. Now using MPPT, I should get that value. So similarly, now power this is current versus voltage. Now power versus voltage also I can draw PV curve. So power is how much you got, sir? 200 into 49 panels. How much it was? 9,800 something, no?
200 into 49. 9,800 means around 10,000.
This much, you know?
Yeah.
Ideal characteristics is this much. And voltage is this much. But VMP will be same 1288. You understand? VMP for this one is 1288 only. IMP is 9,800 and current is 7.81, but these are the characteristics I should expect. But during shading condition, this is coming, so I need to extract. Now we will see parallel configuration will give you better results. All are connected in parallel, no variations. Okay, so in parallel configuration, voltage will be equal to one module. Voltage will be equal to one module. One module voltage how much, sir? In parallel connection,
yeah.
In parallel configuration, all the modules are connected in parallel. So voltage will be equal to
32.
one module.
32.
So voltage is 32.9. Current should be equal to 49 into IM.
Yes.
How much it is?
8.21 into 49. 8.21 into 49.
Approximately 400.
10.3 something.
Approximately 400. These are simulation results actually. Okay, approximately we will get 400. So now shading is happened. Due to that, there is a variation is there. Due to shading, there is a variation. So similarly, power will be same. Power will not change.
Yeah, series parallel power remains same.
So next series parallel I have taken. So in the first one, high voltage, low current application, power is same. Second one, low voltage, high current application. Third one is series parallel. In the series parallel configuration, what happened? Seven are connected in series in a string. 7 are connected in a series in a string. So voltage will be how much? 7 into Vm. How much it will be? Can you tell me? 7 into Vm. 7 into 32.8. 32.9. 33 you can take.
33 also. 33. 7. Approximately 231.
So this is what? Medium voltage. What about current, sir? Current also will be string current. I told you it will be of string current need to be taken. String current in the sense 7 times IM value. 7 into 7 into 8 point.
Approximately 7.6.
8.21 into 7, sir.
ISC you have to take.
8.21, no.
ISC is 8.2.
Yes. Yes. VOC, ISC we are taking.
Okay. 8.21.
Highest point is we are taking VOC ISCs, but maximum power point tracking middle one is 7.61, 26.3 we are taking. I'm calculating highest value. How much
57.47.
So approximately 60. This is 57 here.
Yeah, 60. Yeah.
So we are getting medium current, medium voltage. Is it okay?
Yes.
Now power is same here also. You observe. Even
yes.
power is
10,000.
approximately 10,000 10,000 kilowatt. Is it okay? Now even other bridge link honeycomb, if I take also, it will come similarly. Do you understand how the simulations are varied? Okay, now let me take you to modeling. I'll show you.
MATLAB 2022.
So it is getting ready. So first I will try to show you one PV array I will take. The first one I have explained is when constant radiance you have taken, when temperature is varied, how it is. When temperature, it is ready. New model I will take. So I'm taking new model. You might be knowing, no? When I want to design, you select new. In that Simulink model, you click. In that blank model, I'm taking. It is visible, no? From the blank model, you go to library. In the library, just click PV array. So we have already PV array is available. You select that. Is it visible? My screen is visible, no?
Yes, sir.
Okay. Now, as I said, you double click on it. If you double click, strings you take one, parallel strings one you take. Here user defined is there. Now what I have taken, the previous model which I have shown, Kaisora KC200 GT, isn't it? So now I have an option. There are n number of panels are there. Okay. So suppose 180M if I take, this is 180 watt, 72 cells. So Kaisora KCGT I will take. There are different models are there. One is with 160 watt, 170 watt, 225 watt, 230 watt. It's you have to select which one you want. Okay. So you can select as per your specification, model design. I want 10 kilowatt system. I will select in such a way that are 5 kilowatt system. So in simulations, you have a number of options are there. So I have selected Kaisora KC200 GT I have taken. So let me show you here that value, whatever I have taken. This one, Kaisora KC Solar 200 GT. I am applying it. You see, these values are correct now, whichever I have shown there. 200.143, then VOC 32.9, short circuit current 8.21, 26.3 is the VMP, IMP is 7.61. Is the same values which I have taken. Is it okay? Suppose 200 GT I am not taking. I am taking 250 watt. Let us suppose. If I want 250 watt panel, you select that, apply 250 watt panel. Open circuit voltage will become how much? 36.9. Short circuit current is 9 amperes and VMP 29.8, IMP is 8.39. Do you understand? we can select
Sir,
different mode. Yes, sir.
whether the data which is coming here, is it a empirical data or the data sheet which is provided by the manufacturer?
Yes, it is provided which by manufacturers only, sir, with the
Okay.
data. It is not user defined. First one only user defined is there. You can design your own data if you
Okay.
wish, but otherwise these are the modules which are available.
Okay, these are already available models.
So these are the models which are given by some OEM people and which is of defined values based on the formulas.
Okay.
Exact. Okay, now let me consider. I want to take one module. Okay, so PV array I am taking. One is of 25 degrees. Different irradiances I am taking at 1000. Constant temperature. Different irradiances I am taking. First plot. Okay, you check. Now temperature is constant. First one is 100 watt per meter square. What is your value? Your VOC is 32.9. Short circuit current is 8.21. The power is 200 watt for one module. One by one I have taken. Try to understand. One by one is only one module I have taken. Now, if it is 1000 watt per meter square, 8.21. Can you observe this 8.21? Is it okay? Excuse me.
Yes, sir, it is okay.
1000 watt per meter square. Now, when you have taken 1000 watt per meter square, voltage is 32.9. Is it correct?
Yes, yes, it is showing.
Now, when you taken, this is PV curve, power versus 32.9. And what about this current is approximately 200 is there. Now, I have reduced that value to which one? 500 watt per meter square, second one. Then what happened? The voltage is 31.9. The current is dropped to how much? Current is dropped to 4. Do you understand?
Yes.
When there is, sorry, when we have changed that one to 500 watt per meter square, even which one? 0.1 watt per meter square. That means 100 watt per meter square. 100 watt per meter square, 500 watt per meter square, 1000 watt per meter square. When you vary the irradiance, when you vary the irradiance on the panels, then what happened? Drastically, the current values are changing. Drastically, what happened? The powers also changed. Is it okay? These are VMP points. Here it is 26.3. Can you see?
Yes, sir. Yes, sir.
Okay. I hope you understand. So when you simulate one module, then what is happening? For a one module structure, then temperature is constant. When you are varying irradiance, huge change is there. But now next graph, I will try to consider irradiance is constant and temperature variation I am taking. You try to see what happened. Temperature variation is there, but irradiance is constant. That means light intensity is falling. In the climate, temperature is varied from 25 degrees to 45 degrees. Is there any change is there in the current or voltage or powers? Much change not there, no? The previously there was huge variation is there when irradiance is changing. If irradiance is constant and power is this, only temperature is varying. Can you observe this? 25 degrees one curve, second curve is 45 degrees. But the current is almost same. The power is nearby it is. Do you understand? Is it clear? So temperature will not affect the performance of your PV system. Try to understand. Only light intensity, how much is falling on the PV panels, it will only affect. So the shadings will affect a lot on the PV panels. Is it clear? Now, one module itself, string integrated I have taken. This is a string integrated converters. Okay, series connected. We have solved no yesterday. 6 are in series, 6 are parallel strings if I take. 6 series, 6 parallel strings. Now let me draw this. How much will increase? 6 series, 6 parallel strings. Oh, okay. You understand? Now, anyway, one model I will take and I'll show you. Is it fine? No. Do you understand? 6 series, 6 parallel. What will happen? Voltage will be 6 times will be multiplied. Current will be 6 times will be multiplied. Or 10 I will take. It will be easy for you for calculation. 10 if I take. Do you understand? Now, 10 series connected panels I have taken, 10 parallel connected I have taken. That is string integrated. In your one string, 10 series are there, 10 parallel are there. So how much it will be voltage? Can you tell me? 10 modules are in series, 10 modules are in parallel. Voltage will be how much? Excuse me. I have the voltage of 32.9. 10 modules connected in series in a string. So how much I should get voltage?
329.
Yes. 10 modules are in parallel means?
Parallel it will remain same.
No. Parallel. No, sir. Series parallel structure it is. It is a series parallel structure.
10 are
in a series.
Okay.
In a series parallel structure, in a string, 10 are there. Parallel strings are 10 are there. Parallel strings 10 are there means 80 amperes, 82 will come. No. It is a series parallel structure.
Yes, series parallel.
The current will be 10 into 82. So current is 82. Then voltage is, do you understand? Series parallel it is. Voltage is 329. Current is 82. The power will be 10 times the normal one. 20,000, no, 20 kilowatt.
20 kilowatt.
This is 20 kilowatt. So when you are taking one module value also, you can fix it to this range, or else individual modules also can be taken. Now let me show you my models. I'll open it. Lord. One second. Otherwise I open one more. Okay, this one can you see? So here, how many modules I have taken? 3 by 3. Can you observe this? Now what I need to do, one module I have taken, previous one only I will open, I will show you. So here one module I have taken. So this is 1, 1. I'll apply. I will take. So this is 1. Here what is there? So next, series connection if I want to do. This is one module, 3 by 3 system I want to design. This is one module. Then this is the second one, third one. Is it clear? Similarly, I need to make 3 more. Then I need to take 3 more, 3 by 3. Is it okay? Do you understand? I have considered 1, then I have added. So 3 by 3, 9 I have taken. Is it okay? series configuration I am connecting. So I have taken first one. Am I audible? Then tell me some response. See, initially when you are taking, what we need to consider is from the library, okay, you take a PV panel. So in that, so then you need to select not user defined, then whichever the model is required, you try to take. So this one I have taken. Then here number of strings are one by one I am taking, that means one module one by one. So this is one module. So second module with a left arrow I have copied. Fine. Then similarly one more I have taken. So I want to design 3 cross 3. So I have taken 1, 2. Now next what I need to do, IR is irradiance, T is temperature. So temperature what I need to do, I need to add a block, constant block. Temperature how much I need to set? What is the standard temperature for a PV panel? I told you. What is the irradiance? Can you tell me? Irradiance is how much value? Irradiance how much we should consider here? Excuse me. Are you there? I'm audible, no? But then tell me, so how much we need to consider irradiance? So irradiance should be 1000, no? See, here irradiance constant block you take. In the constant block keep 1000 watt per meter square. Temperature is 25 degrees we need to consider. So each block you consider 1025. So you need to consider 1025. So and one more thing, bypass diodes I need to consider. So that is parallel diode you can consider. So that is a normal diode can be taken. So like this, all the PV modules need to be taken with 1000. This is uniform condition, 25 degrees centigrade. So now what I did, so I have taken 9 modules. So here what I have done, the first module one is connected to second module is connected to third module. Now third module is connected to this one, 4 to 5, 5 to 6, 6 to 7, then 8. Now, here what I have taken, I need to measure voltage and current, isn't it? If I want to measure a voltage and current, what I have done, the current measurement block I have included. Second one is that is in series with the line. Current if I want to measure, it is series with the line I have taken. I want to measure the voltage. So voltage what I have taken? Voltage across the total I have taken. This is the line. This is the first line. Voltage across all the panels I have taken. So voltage across all 9 modules will be there. So in the series configuration, 9 modules I have taken. So 9 modules are in series. So how much amount of voltage will be there approximately? So this is which model I have taken. So the Kaisera KC 200 GT 11. Okay. So this is 26.3. And VOC is 32.9. So VOC I have taken 32.9. 9 modules are there. 9 modules into 32.9. How much will be there? In a series configuration, voltages are added together, isn't it? So how much voltage?
296.
So approximately 300 is there. So what I did is, okay, so there is one, the controlled voltage source block need to be considered. Okay, so it can be taken with The ramp signal up to 300 I have taken. Why? The voltage need to be drawn up to 300 is enough. Now, I want IV curve, PV curve. So IV graph is an XY graph. So what I have taken, so from current, one output, from the voltage, one output I have taken, which is given to IV curve. So here IV curve is, so one is current I have connected IV. Second one is from voltage I have taken. So this is called XY graph, not normal graph. You need to consider XY graph need to be taken. Is it okay? So XY graph need to be taken, which will draw. Next one is power I want to calculate. If I want to PV curve, I don't have a power calculation. So what I did, multiplier I have taken product, current and voltage, both are multiplied here. Output is given to PV curve. So that is current block. One is current, second one is voltage I have taken. So both are multiplied, I got the power. And second one is PV curve, second one is V is taken. Is it okay? How I have constructed, do you understand? First one PV module is taken, then the constant blocks are taken, then constant blocks are taken. One is 100, second constant block I have taken with 25. So after that I have connected all diodes. Now I'll run the show. And one more important, everyone knows it. So there is graphic user interface, discrete, it has to be connected. You know, no, I hope. So here I have taken power GUI block. Power GUI block I have taken in discrete 50 e power minus 6. So whatever the results I have shown here, this is for 7 by 7 system. But here I am going to draw for 3 by 3 system. Let me show you that. Can you see the curve? Approximately it is going up to 320 and 8.2. Is it okay? In series configuration, current is module current, no? And voltage is 9 times the module voltage. Can you check? Is it okay? The PV curve, if you see, the power is from 0 it is taken. The power will be how much you should get? 9 modules you have taken. Power will be how much? When you take 9 modules, the power should be how much? Excuse me. So 9 modules, each module with 200 watt.
$1,800.
So approximately 1800 you got. Is it okay?
Yes, yes.
Okay. Now let me consider. Even I can consider like this. Oh, this is series parallel. I'll consider series. series column shading will take. Now this is the series configuration. I want to take column shading. First column is shaded. Can you observe? Instead of 1000, I have entered 200 watt, 800 watt, 500 watt. Is it okay? First column is shaded. Remaining are not shaded. So shall I enter 500, 500, 500? Is it okay? First column is shaded with 500, maybe 700, maybe 900 I'm entering. So when column is shaded, only first column, remaining values are as it is. Now I will try to see how during column shading condition, how the values will change, we will see. You observe, previous one was uniform. Now can you see? There is a local maxima scheme due to column shading. Now you see PV curve also. Do you observe? Do you understand? If there is a one column is shaded, that to 500, 700 like that is there. If it is 200, then maybe 400, and if I take 600, if I run, that means 200 means more shaded, less irradiance. You should get worse than previous one. Do you observe that? Is it okay?
Yes, sir. Yes, sir. It is coming down actually.
That's what. Even I will consider this 1000. This one I will consider 1000. Okay, diagonal shading I am taking. Diagonal shading of this one 200. Is it okay? Here only I am changing. Diagonal shading 1, 1, 1, 2, 2. This one 200, 200, 200 I am taking. Let me show you. This is diagonal shaded. In all three it is shaded. Now you see. Do you observe? This is the power curve. Is it clear? So you can't expect the same values in which one? All the shading conditions. If shading conditions varies, the values are these values will be changing. This is 1000. Okay, 200. Now I will show you some other connection. Open the model. This is a parallel configuration. All the modules are parallelly connected. Okay. This is one row shaded condition I have taken. Okay. So here voltage will be how much? In parallel configuration, voltage should be how much? See, first one is in parallel with second one, second is in parallel with third one is in parallel with fourth. Okay. One string only I have taken. Okay. So in the parallel configuration, the voltage will be of single module, current will be added together. Okay. So run the. So how much voltage I need to set? So it is here constant voltage will be maximum 50 I have set because I know that it is 32.9 is maximum voltage need to be drawn. Can you see this? So series parallel structure is series parallel structure is similar with that one series structure, but whereas third one was connected to fourth one previously, but now series parallel structure, can you observe in the first column 1 2 3 will be connected, second string 3 more connected, fourth string, third string 3 more are connected. Now each string is connected in parallel. Do you observe this? Is it okay? The series parallel connection, is it okay?
Yes, sir. Yes, sir.
So now we'll run it. We'll see how it will be. Sir. Then good. I'll see. Yes, sir. I'll see. Thank you. It is 80% done. Now, can you? Now, how much voltage, how much current should be there in the this one? Can you tell me? Series parallel configuration. What should be the voltage? What should be the current? .9 is voltage, 8.21 is current.
Voltage is showing 98.7, sir.
Voltage is 32 point. Yes. So here constant voltage block, how much we should take? 100.
100, yes. We have to set the 100, no?
Yes.
The set value should be 100.
So
Current will be around 25 ampere.
yes. So now can we see? So 100 voltage.
Yeah.
Power is?
Voltage to current, no? Right.
Correct, no?
Yes.
There are even IV curves we can design like this. Okay. Now irradiance also we can calculate. Let me show you.
Sir, any scope is there for research in this area?
Yes, no.
In this area, because
Sir,
most of the combinations are already done, I guess.
Sir, 1 minute. I'll show you if you want. Scholar.google.com.
Okay.
Maximum power extraction I will put. See how many papers are coming. You see 2023 itself. Photovoltaic.
Okay.
24 onwards, you see. Extraction of PV, MPPT.
Yes.
So even PV system, if you take since 2024, how many are there? Even if you take MPPT review if you see also. There are several papers are there, sir. So what I mean to tell you is huge research is going on. The people are publishing many papers in that. Even why? See, even my students know. I'll show you. There are.
Okay.
This is my. We have published review paper on IEEE CSCA journal of MPPT techniques, cited by 426 members. IIT we published only this one. So now you see there are modeling of PV systems, real time of. I'll show you. Year wise. EV, there are PV with MPPT is there. There are PV array topologies are there. There are some other subjects also there.
Right.
EV is there. EV, PV, and grid connected, even gray wolf optimization, inverter topologies for PV system, converter topologies, V2X topologies. There are several papers are there on. Even these are published in SCA journals, IEEE transactions.
Okay.
Okay, there is a huge scope is there on PV and EV, even smart grid, sir. These are the things.
We have one module, sir, we have bought for our laboratory. It is a solar module. But that is not properly utilized by the faculty.
Okay.
Even good kind of experiments also not getting executed.
So there are high chances are there, sir.
Right.
So let me show you. There are more models are there. So 1 second. Give me a minute. I'll open.
अकाउंट नाही ते ह्याचं देतो ना तुम्हाला त्यांचं UPI ID. UPI ID.
अरे UPI ID माझ्याकडे.
Okay, fine. Now, if suppose it will take so much time for let me show you. There is a bridge link configuration I told you, no? So bridge link configuration I will open. So this is the bridge link configuration. Can you see? So this is bridge link system. Okay. Now what we are doing? This is how many I have shown you results previously? 7 by 7. 49 are there. Okay. So if 7 by 7 are there, then how much voltage I need to keep? 7 into. So here again IPV, VPV, IV curve, PV curves are there. Now we will try to see in the bridge link configuration how it should be connected. Can you tell me? Alternate PV module should be tied to try to see. This is the first link. Second link should be left. There is a third link. The fourth should be left. Fifth link. So then here it should be left. Sixth one. Do you understand? So this is a bridge link configuration. The alternate should be connected. Okay. But it will take so much time. Do you understand how the bridge link configuration to be considered? Can you see this? Excuse me. Am I audible?
Yes, sir. Yes, sir.
Then can you see?
No, some shabby screen seems.
Is it okay?
Yeah, now it is seen, yes.
So in the bridging configuration, what we are doing is, so alternate these panels will be connected. You see, the first type we left it, then this alternate, like four modules together will be a type. Next, four modules together, one more type. Four modules together, a type. So like this, it will be considered. So here, since in the first one it is there, second one I should not take. So second one, by leaving that alternate I have to take. Is it okay? When I take second one, I have to leave the first one and second one alternatingly I have to take. Then third one will be as first one. Fourth one will be as second one. Is it clear?
Yes, sir. Yes, sir.
I hope you understand, no?
Yes, sir. Yes, sir.
So, but the problem is 7 by 7 structure, no? You see, 3 by 3 structure easily it happened. 7 by 7 structure now, how much percentage over? Only 4%. It will take so much time. The previous one, quickly it has given. Now, when
This
size increases,
orthogonal combination takes time.
Since you have increased more number of panels, then the complexity is increased, then definitely competition time will increase. Okay, now so for this one, how it is, all together system I created, from there I have taken IPV, then VPV, then output is taken. So I will show you one more thing, stopping this. Okay, so now TCT structure I will show you. Total cross state structure. This is the total cross state structure. Can you observe? All the modules are connected. This is type. All modules are connected together. Is it okay? You understand?
Yes, sir. Yes. TCT model.
Total cross state. In the total cross state, all the modules will be connected. Now here, what I have done, so lower shading condition I have taken. Okay. So then output of IVPV curve will be taken. So even similar way, we can simulate with MPPT technique also. So let me show you MPPT technique, how it will be taken. Start this model. Now, suppose one module I have taken, only one module I have taken. So I want to create variable temperature. How to create variable temperature? Can you tell me? See, previously I have taken constant temperature. Do you understand? Previously I have taken constant temperature. But if temperature varying, now till now what we have seen? Till now we have seen the variable irradiance we have taken. We have changed the values. If I want to change the variable temperature on each and every PV module, I want to change. So how to change? Can you tell me? See, previously irradiance at different levels I have changed. 200, 1000, different values I have changed. But temperatures are constant I have taken. Now on each module, morning to evening I am simulating. But that time there is a temperature variation is there. If I want to consider that, what attribute I need to consider? Can you tell me? Do you understand my question? Excuse me.
No, sir. No, sir. Can you just come again?
Try to understand. Now there are 9 modules are there.
Right.
On 9 modules, 1000 watt per meter square constant irradiance and 25 degrees centigrade we are considered.
Okay.
Now different irradiance conditions also we have taken, like there is a column shading, there is a row shading, or there is a diagonal shading. Different conditions we have taken, isn't it? Now what I am telling, morning to evening temperature variation is there. If I want to consider temperature variation, if it is there also, less effect is there on the performance. But
Right.
if I want to consider the temperature variations also, morning to evening I want to change. I don't want to consider 25 degrees centigrade only. I want to consider variations in the temperature. Which block to be considered?
That ramp block we have to consider, no?
So 1 minute I'll show you that irradiance temperature is, instead of this temperature, see here this is a constant temperature, isn't it?
Yeah, we have to select ramp one.
Now what we need to consider is not ramp one, this one, signal builder I can take.
Okay.
So signal builder with, okay, so 0 to 0.4 seconds, how much value, then
25.
0.4, how much temperature is there,
So
then
it will show the
0.4
real-time
to
changes in the temperature.
yes. So temperature variations, if you measure and approximately if you give, even we can create like this. Same thing on one module. If I take, suppose one module I'm taking, only one module I'm taking, then even irradiance also some morning to evening if it is changing. So with the signal attributor, even I can change the irradiance also. I can check, I can change and I can check. Do you understand?
Yes.
See, variable irradiance I will show you. Suppose irradiance is 1000. No, 1 minute. Variable. Oh, in this it is not there. Now basic one I will take and I'll show you how MPPT can be applied. This one I'll close. Now see, when MPPT taken, no, basic one I'm taking. So first PV array, then 1000 watt per meter square, then temperature. Now I have calculated IPV, then VPV calculated. Then after that, I have considered the converter. The converter is taken. After taking the converter, then what I need to consider? MPPT algorithm need to be considered. So for considering MPPT algorithm, what I have taken? Now, IPV is given as an input, and for an MPPT, VPV is given as an input. IPV, VPV given to input to P&O. Second thing is duty cycle. So in this, what I will put is, I will write an algorithm. What is that algorithm? So one MPPT technique is the P and O particles. This one perturb and absorb method is the P and O algorithm. So we need to initialize P and O. What is the voltage? What is the current? Initialization of the duty cycle value. What is the maximum? What is the minimum value? What is the delta function change? So initially we need to take the voltage, powers, and other values. Then after that power calculation, okay, V into I. Change in voltage is V minus V volt. Change in power is V minus V volt. That conditions no. So there is an algorithm is there. That entire algorithm in the P and O we need to mention. Then after mentioning that, then we need to take output characteristics. So we can implement even MPPT algorithm also. So to extract the maximum power. But here I will get XY graphs I will not take, normal graphs I have taken. Okay, so these curves are, one is of duty cycle, one is of VPV 25.78 I got VPV, IPV is 7.7, power I got 199. If you observe, one module 25, IPV is 7.7, power is 199 I got. So these are the output parameters. Output of, if you observe, output current, output voltage. So one is converter voltage, second one is the converter current, third one is converter power. So converter voltage will be how much? So input is 25 volts, output I am taking. So output is, since this one converter I have taken, so inductance values, capacitance values will be designed as per input output ratio, how much is required. That one you know, no? So input output, how much I want. So based on that one, the converter, inductor, capacitors will be decided. So now you see how much I got, 100 volts. The current is 2 amperes. So with MPPT, we can boost the power also. Voltage can be enhanced. Even we can apply fuzzy logic system, or different methods can be applied. Now, do you understand these curves? How to take, how to consider?
Hello, sir.
Yes.
Ideally, how much time, I mean, to understand this MATLAB and all, how much time we should take?
Sir, basically, if you know MATLAB normally, then it is easy for you to construct, sir. But basic understanding, if it is there, then at least within a month, it will be easily we can work on it. But the thing is, base level 3x3, 4x4 doing is very easy.
Okay.
But when it goes for high power applications like 7x7, 9x9, then it will go for larger time. So that may be issue. So see here I will show you single module one. I will show you, sir. Single module I have taken. It is easy. Can you see?
Yes.
So till now I have shown you, which is of high circuits I have shown you. No. So yes. Let me close that.
Series parallel you are shown.
So rather than that one module, let me show you. It will be more easy for you.
Because I am in diploma, so we don't use MATLAB as such.
Sir. Okay. This is single module, sir. Okay. So from PV array, one module I have taken. Okay. Kaisora KCGT I have taken. One parallel string, one series string I have taken. So then 1000 watt per meter square I have taken. Then 25 is taken. Sir, if you want, see, offline session I can take for you. Maybe your same college or what, I don't know. Different college.
In Mumbai, sir. I'm in Mumbai.
See, wherever it may be. Okay. If they organize, if you organize offline session, you can contact me later. Even MATLAB session separately from scratch to till connection, I will teach you. Don't worry. You call me later.
Okay, sir.
Okay. Sir, now you see. there is a parallel string 1, series string 1, one module I have taken. Now what I am doing is here, now if you observe, now if you observe, the radians 1000 I have taken, then temperature 25 I have taken. Now I want current need to be sensed, voltage need to be sensed. So from plus I have connected to IPV. From second part across these two voltage I have connected. So I want IV curve, PV curve, what I have taken, XY graph I have taken. So in the XY graph, one is voltage I have connected, second one is current I have connected. Similarly, power I want, for a power what I have taken, so power directly not there, PV curve. So for P, what I did, multiplier I have taken. So one is from current I have taken, second is from voltage I have taken.
Yes.
So both are multiplied, I got the power. So power, voltage, then this one. So single module I have taken. So how much current and how much voltage should be there? 32.9, 8.21.
8.21, yes.
Okay, let me run that. Do you understand? 8.21. It went.
Voltage 32.
Little bit. Okay.
The graph
8.21. Graph is when.
Extrapolation is there. Yes.
This is output. Then the PV curve is there. Okay. So now what I mean to tell you is with the single module, next one what I will show you is this one I will show you with this is basic simulation. Okay, so this is a PV module. Now with single module with variable insulation I'm taking. Suppose variable insulation in the sense irradiance is changed. Only one module I have taken. Fine. One module. Temperature is constant. Now what I'm doing, morning to evening irradiance change. Irradiance change means how much I can take. Maximum is 1000 watt. Isn't it?
Yes.
Remaining will be 400 watt.
400, 600.
Per meter square or 500 or 600, or it is changing from morning to evening. So if I take like this, then even irradiance change is there, I can run, I can see the curve also. So when irradiance change is there, definitely plot what will happen. So there is multiple peaks will come. Since one module I have taken, that is coming like that. Otherwise, many modules it came nicely. You observed, no?
Oh yeah.
So this is with
the group effect. That is a group.
PV effect.
Yeah.
Now, similarly, even we can see with temperature variations also. Okay. I hope conventional. With variable temperature also can be taken. Okay. So first you can try with variable temperature. Temperature should be in between 20 to 50 I have taken. So I have run that. Now temperature variation is there. So but much change should not happen. It should come properly. Do you understand?
Yes.
So this is what now. So single module simulation or many modules, this way it can be done. So but if you consider normal one, normal configurations PV, series parallel, is a series parallel structure. Just 2 cross 2 I have taken. Can you observe? 1000, 1000,
400, 200.
Okay, 1000 only I will take first.
Okay.
Then 1000 I will take.
All 1000.
All 1000 I have taken. So now you will get better result. Okay.
Yes.
2 by 2 system. How much voltage should be there? Can you tell me? 2 cross 2. 2 cross 2 means two strings are in series. How much voltage should be there?
65 point.
How much current?
Current will be
In one string current is
16 point something.
yes. So now can you see that? Can you visualize that? In the IV curves, how much we are getting? 16
Yes,
point
16 point
something.
something. Yes, yes, correct.
Understood, no?
Yes.
See, powers how much you will get? 4 modules are there.
64 into this.
4 modules, no? 4 modules into 200 watt. So approximately,
approximately 800 watts.
yes. Sorry. You see. Oh, yes. One minute. I'll give you one more question. Even 3 cross 3 if I take also
3 by
properly.
3. 3 by 3 model.
We have already done this. Okay. I hope you understand, no?
Yes,
So
sir.
how to design modules is, so we need to first PV array need to be taken. After that, irradiance as well as temperature need to be selected. Then the blocks need to be connected. So once it is done, then it is either series connected or parallel connected. Based on that one voltage, that voltage limiter need to be taken. Output X by graph has to be taken. So for IV, PV curves to measure, the current measurement, voltage measurement block to be taken. So you see here, during shading conditions, non-shading conditions also we have seen. So these are the effects. Okay, no? This is during shading condition. Right? Now, is there any queries? Can you tell me? Is there any queries? I hope we started from where we started. We started from smart electric grid, past electric grid how it was, present grid how it is, the future grid how it will be. So we started from there. Then after that, then we have discussed about the renewable energy significance. So there we have seen what is that installation capacity wise we have seen. When you consider installation capacities, what was that? The based on installation capacity of which one we have taken? Can we revise just for a minute what we discussed? So in this module, architecture we have taken, no? So architecture of the past grid, what was there? Can you tell me? Architecture of the past grid. So there was only thermal generation was there, which is transmitted and distributed. Okay. So but there is no middle, distributed generations were not there, whereas in the present grid we have the DGs in the form of solar parks are there. Am I clear? Am I getting? Okay.
Yes, sir. Yes.
Yes. Okay.
Yes,
Then
sir.
after that, what you have taken? Smart electric grid we have taken. In that, which includes we have which one is there? So we have generation is included, solar PV systems, wind energy systems are there, utility as well as throughout also there. Even EV PV charging stations are there. Okay. Then next day we have discussed about the importance of renewable energy, share of fossil fuels how much was there, then share of non-fossil fuels how much is there, then after that individually we have discussed about wind energy how much share, then solar PV systems how much share is there. So accordingly, then after that we have also discussed about public sector, private sector, state sector, what is the how much contributions are there, 25, 25, 52, 23, 24, 52 I think. Then after that, even grid wise, north grid, southern grid, as well as north and south grid wise, how much amount of the powers are installed we have seen. So then per, per year wise, how much percentage is increased we have seen. What is the installation capacities? Then we have started about how the solar energy. Okay, then after that PV cell, PV module, PV array, then numericals on PV cell, module and arrays we have seen. Then after that we have seen the PV config, IV characteristics of and during irradiance condition, during which one? temperature constant conditions. Then during shading conditions we have seen, and different configurations we have observed. Then different MPPT techniques discussed. Then standalone system, grid connected PV system, as well as hybrid systems we have seen. Then after that we have also discussed about what? Then modeling, mathematical modeling of a PV cell, PV array we have seen. Then MATLAB models of, even today we have seen about applications, and what are the solar parks available in India also we have seen. Okay, even MATLAB modeling of one module we have taken. That modules are connected together. PV array can be formed. Series we have seen, parallel, series, parallel. The even bridge link I have shown you, TCT I have shown you. Okay, during both shading and non-shading conditions also we have observed. Any queries on these topics which we discussed?
No, sir.
At least do you understand? It is more than a semester work.
Yes.
Yes, sir.
Only the difficulty is to understand MATLAB, sir.
Sir, no session, no
Yes,
one
sir.
will
There
give
is
you
a little bit difficulty to understand MATLAB.
MATLAB will be difficult, but if you try, you may get. We'll see.
Sir, can we introduce this subject as a subject to the diploma students as well?
Yes, sir. You can introduce. That won't be any problem. Initially, if you need any help, I will. Okay. So that it will be in line with the industry. What?
I think Priyanka Kamble ma'am.
Yes, sir. Yes, sir.
I think we don't have this course as a course.
Yes, sir. No, sir. No, sir.
For diploma, I think we don't have this course. At MSBT level also this course is not there.
No, sir. MSPT not included that much syllabus.
In future is what is going to happen is
Right.
solar PV systems, electric vehicles, and battery management system will play a vital role. So at least person can understand basics of, see, now we started from basics, and at least person can, what is a cell, what is a module, how the installation can happen.
At least
So
at least for 1 by 1 or 2 cross 2 or 3 cross 3.
Yes, that much people can do, sir. That much people can do. Even you people understood. No, even numericals we have solved.
Yes, yes.
So
numericals I understood, sir. Yes.
You could able to understand that even 2 cross 2 also you could able to answer no. At least what should be the output you understood, isn't it? Right. See, typical no need to go ahead with 4 cross 4 or 7 cross 7. At least basic up to 3 by 3 easily can be solved. If you need any assistance, I can help you.
Sure. Madam, sir, we need your number and email ID as well.
Number is 7588 133 009, sir.
Just 7588.
133
133
009.
009.
Okay. My mail ID is available in the website mikli.suresh@nitgoa.ac.in.
Yeah, that I'll take it from your website, sir.
Any queries, others?
Sir, rainy seasons, what is the position of solar? Absolutely zero? No.
Not like that, sir. At least a small amount of, that's what I told you. No, it's not about this one. At least it is about this one. Which one? How much irradiance, little bit it can be generated. Okay. Not about temperature. So little bit it can extract, sir. Not like fully. See, entire day of rain you can't see, sir.
Right, right.
Some part of time, some small amount of time, it will be there. No, it can be generated.
Something will be there. Something.
So completely full rainy day you can't expect.
Right, right.
But you never see like complete full rains. Like at least there is a half an hour, 1 hour of rain free is there, no?
Right, right.
So it can be.
It can generate some.
It can be adapted and it can be generated, sir. Definitely.
What about reliability issues, sir? How it is reliable in that case?
No, definitely. See, sir, reliability will be very high compared to depending on the grid tomorrow. Compared to depending on the grid, at what time you will have a power supply is there, at what time power supply not there. Rather than that, if you use for water pumping system, you use for water heater system, or any small applications you have used agriculture or residential purpose, definitely to serve your purpose. No, you no need to depend on the regular grid power supply. Even though entire power cut off is there, at least you can generate your power when sun is there.
Okay. But according to you, sir, according to you, what could be the ideal way of using the power in today's scenario?
Sir, now actually we have a renewable energy sources are there, like even wind is there. Windmills also can generate very huge power based on the height of the tower, based on the wind blade that parameter how much we have taken. So based on that one tower itself, it starts from maybe uh, 5 kilowatt to so much it can give. Okay, even integration of wind,
Okay.
solar and EVP integrated charging stations, the huge change will happen in the future. And one more thing, batteries which you consider for storage of energy of solar energy or wind energy or maybe EVP integrations. So
Right.
which will there is a way, sir. Huge development you can see in these areas. Future is going to be this one, no,
Yes, yes, of
definitely.
course.
So
Hello, sir. Can we use the hybrid storage system along with this PV generation system for the backup?
yes, madam. Yes, you can consider as a battery. That's why I told you standalone systems. No, compulsory. We need to have a battery to store your PV energy. So we need to see like it can give you DC energy only. We can store the energy and we can reuse it. So hybrid systems are well taken with EV, wind, PV as well as this one. Which one batteries? But selection of battery very important. Rate of charge up and rate of discharge, state of charge, state of health of a battery, and you have to take care about that.
Yes, I
Understood?
read about that. The hybrid storage system we can use here instead of a hybrid generations means
Mm.
PV with wind. Instead of that, we can use the alone PV system with the hybrid storage system like super capacitor and the lithium
Mm.
ion batteries or lead acid batteries or lithium ion batteries.
That's
So,
what, madam. You can consider
what are
which
the?
one PV with even two or three of energy storage elements can be
Huh.
mixed. But the thing is how compatible. So which one will be how much storage, which one will be secondary one, which one will be primary. So you need to decide. So based on the charging and discharging rates, based on the state of health of a battery, based on the state of charge of a battery. So one can be primary storage, one can be secondary storage. What I mean is, suppose straight away when the things are there, one can act as a auxiliary or one can act as a main storage also. Understood, no?
Yes, 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 understood.
So like that, if
So
you keep okay.
if
Otherwise, both.
easily,
Mm.
yes, 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 talk. You talk.
Yeah, tell me, madam.
Actually, I heard about that there is a super capacitor and lithium battery. This is the most famous combination which
Mm.
are used in the hybrid storage system. But can we use the lithium ion batteries and lead acid batteries together for this? Are they compatible or less
That's
compatible than that previous one?
no, super capacitors definitely it will give you the high flexibility as well as high charging rates it will give you. See, we need to see in future, no, which one is quickly degrading also we need to see now, madam. See, it's the electric properties, which one is losing and which one is giving you best also you need to see. No, in that way, the
Yes.
better option only we need to take, not on the, see, these batteries also within 5 years it is going to be like okay, no, so you need to rechange. Understood?
Yes, yes,
Suppose
yes, yes.
so batteries, no, its life is not more than 8 years or 10 years. So we need to select a optimal batteries and optimal charging storage devices in such a way that we should provide you longer run, at least. Understood, no? So in that
Yes, yes.
combination you can try. It's based on what parameters you are looking after. It can be done, madam, not a problem. But the thing is, you need
For
to
a small
compromise, you need to,
application, we can use that
yes,
combination. For
yes,
small application,
small
rural
applications
areas
okay.
where,
Yes,
yes, yes, yes, yes.
small applications okay, madam. If you want to go for larger applications where money is not a problem, so where efficiency matters, then the combination will change. Where some compromise is required, rural applications, small scale applications, yes, you can compromise on some parameters of technical parameters you are using for your standalone application, not grid. Yes, you can.
Yes, okay. Thank you, sir.
Thank you. Do people understand that 5 days? Is it okay?
Yes, sir.
Yes, yes, sir.
Okay. Ma'am. So, Priyanka madam, if no queries, can you conclude otherwise?
Yes, sir. No, sir, there is no any queries. So apart from our institute, Dr. Bapuji Sarangi College of Engineering and Technology, I just thankful to you, sir, because you not only share basic all the basic, also you include simulation MATLAB, and you just describe all the renewable sources. So I personally so thankful to you, sir, and also you define numericals in very smoothly way, sir.
Yeah.
If any query, any participant, please ask.
Thank you, one and all, for your patience. Last 5 days, no, I don't know. So many are faculty. I hope so. Maybe longer sessions.
Sir, actually, we must appreciate you single-handedly conducted the entire workshop.
Thank you, thank you. No, sir, this is habituated. Actually, what happened, even some MATLAB sessions, no, from half wave rectifier to converters, conventional converters, even from MPPT till grid connection. 5 days a crash
Sir,
course I have taken to
is it
MATLAB
the
sessions also.
is it the case that now here on students will be learning only on MATLAB only rather
Yes,
than
sir. I have taken a crash course, 5 days crash course to some of the students. 5 days I went to their institute and I explained them.
Okay.
Even half
Then
days I
last
stayed
class we have
during
also
vacation time
discussed
also.
about
See what happened.
mathematical modeling
See
of
when we
PV
come there, what happened, sir? I'll tell you frankly. Now through online I'm taking
configurations
this.
we have seen. So we have
See,
a series,
informal.
parallel,
What
series,
happened?
parallel,
Now I am
bridge
explaining you. But
manekin
when it comes to the
configurations are there.
MATLAB,
Right.
online I can explain,
So
no
today
problem
we are
at
going
all.
to see
5 days crash course I can take MATLAB, I can
so what is the
explain
grid connected
initially
PV
starting
systems
from
and
scratch to
about
first we
standalone
can
systems
design
we will
half wave
see.
rectifier,
So these are the
then
things yesterday we
controlled
have discussed
uncontrolled
already.
rectifier, then controlled rectifier,
the
then after
different
that
combinations? Yeah.
three phase rectifiers, then three phase rectifier. So suppose normal diode rectifier to bridge rectifier, then after that one three phase rectifier, three phase inverters, dual converters, then buck converter, boost converter, buck boost, like rectifier to then converter, convert to inverter models, single phase to three phase. Then after that I have explained them solar systems. So
Okay.
module, PV systems, then after that MPPT, even power quality issues. So even if anyone is interested, fuzzy logic controller I have worked like.
So at diploma, we are from diploma, sir. We at
uh,
our level student are we are expecting.
that's what. Even modeling of small things, if we can do, so that one also I can explain. So what happened if we come personally? At least we can stay with the people, and we can see how it is working. That is possible, or else online also possible, sir. Both are quite okay. Either
Yeah,
online
online is
or
also
one time if Saturday, Sundays or some period if you conduct also offline also okay, or online also fine. But the thing is, for diploma student, BTech students, we can start from some level. But diploma students, we need to start from some scratch.
yeah,
So
yeah. No, they are talented. It's not like that they don't have.
no, they will be talented, but at least we need to give a little push to them. They will cope
Yes.
up. So we should understand the students, and we need to change our way of teaching so that it will be easy. So that's why, sir, even numericals I added in this. Actually there are group of people.
Numericals, yeah, that gives a real-time picture, you know.
So that's why mixed here. What happened, all the things including introduction to till applications,
Right.
including MATLAB, including numericals, everything mixed up I have given so that you will not get bored.
You are based in this Goa only, sir.
Yes, sir. Last 10, 12 years, I'm working with NIT Goa. I am from Andhra actually.
Okay, but
So I
how
completed.
frequent you come to this side, Mumbai side and all?
It's night journey only, no, sir. Not a problem. It
Okay.
can be. So when you organize, it
You
can
may be
come.
coming to IIT Bombay as well sometime, you know.
Yes, sir. Yes, sir. Yes, sir. So it is nearby only. That's not a real issue. Distance not a problem, sir. Nowadays, but
Right.
only one thing we need to see like accordingly timings. Like once we can discuss and we can do that, sir. Not a problem.
Right. So how much, sir? 1 week we have to plan for MATLAB. 1 week will be sufficient.
Yes, you call me, sir, personally. I'll discuss with you.
Okay, okay, no issues.
Okay, rather than this here. Okay. Any other queries? You have number, na, sir. You can call me
Yeah, yeah, I
immediately.
have taken your number, sir.
Yeah, you call me, sir, now
Yeah,
once it is done.
sure.
Any other people? So others should not feel bad. That's right.
No, no,
Otherwise,
no, it's all right.
uh, others, any queries, or else we can conclude.
No, sir, no any queries, and the
Okay.
session is very wonderful.
Yeah. Thank you. Thank you, madam. Can I wind up? Can I log out, ma'am? Yeah, thank you, Ananda. Yeah, thank you.
Yes, yes, sir.
Thank you so much, sir.
Thank you, sir.
Madam, happy Diwali.
Yes, sir. It's a happy Diwali. Happy Diwali to all of you.
Happy Diwali to all of you. Yes, yes.
And just I declare our FDP session is concluded. Thank
Madam,
you.
certificates, when we will get certificates?
Happy Diwali to all of you.
Sir, within 1 or 2 or 3 days, it will be displayed. Okay?
Yeah, yeah, okay. Thank you.
Okay, sir. Thank you.
Thank you, sir.
Thank
Thank you,
you
ma'am.
all. Thank you all. Happy Diwali.
Thank you.